All right, so log base A of 1 is equal to 0. That's a simplifying property. Log base A of the same, whatever the base was, if that's 2 and 2, it's equal to 1. If it's E and E, natural log is log base E, that simplifies to be 1. So there's a nice simplifying there. One more simplifying one, that, or a couple more actually. A with an exponent of log base A of M. What happens here is the log base A and this A that's the base of the exponent cancel each other out, and it simplifies to be M. And then log base A of A, we'll just use to the N power. Again, the log base A and the A here are going to cancel out, and it's just going to give us N, whatever the exponent is there. So we can simplify that. That's really for sure one of the ones that the one from the quiz that you could have used. Now let's get into the ones that are actually expanding and condensing, what useful for that. So remember, logarithms are just exponents, and when we're dealing with exponents, what was the rule for exponents when you multiply things with the same base? You add the exponent. So if I multiply inside of a log, m times n, then I actually can split that apart into a sum, log base A of m plus log base A of n. So a multiplication inside of a log turns into an addition, and then it's for expanding. And if you have an addition of two of the same logs, you can combine those into a multiplication to help. So if multiplication becomes addition, what does division become? Subtraction. It's always top minus bottom. And then one more property that we use here, log base A of m to the r. So again, this one is similar to this one, but the base is different inside of the log there. Log base A of m to the r, that property is the power property, which pulls the r down to the front and becomes log base r times log base A of m. So anytime we got an exponent there, we can drop it to the front and make it multiplication with that. So those 3, 5, 6, and 7 are the ones we're going to use the most as we're expanding and condensing logarithms into either a single log or an expanded form out of that. So the whole process here of expanding will be mainly to help you learn the properties and work with them a little bit more. The process that you use for solving is going to be the condensing side of things. So we'll do expanding first, and then we'll do condensing, and then the next lesson that we'll do, we'll use the condensing mainly to solve logarithmic equations out of that. So let's look at expand. Expand the logarithm. You might see instructions that say write as a sum or difference. Log base 2 of xy. Again, doesn't matter what base the log is, it's always going to work the same no matter what base we're dealing with. The base will come into play when we go to solve the equations later on in the chapter. So, but the property is still the same. So what's going on between the x and the y inside of there? They're multiplication, so they become addition. So log base 2 of x plus log base 2 of y. And you've expanded that into a sum or difference. We want to always look to see if we can expand further, get it to as individual a term as you can. So let's say with log base 3 of 3x squared, not plus, plus x squared y. So this one, what can we do here? Well, before I do that, I need to separate the things that are multiplied together, right, into addition. So this would be log base 3 of 3 plus log base 3 of x squared plus log base 3 of y. And I heard somebody say something about canceling something. Where? The log 3s, what's this become? 1. Okay, so that becomes a 1 because it can simplify a little bit. And then Hunter said, can we drop that 2 to the front? Yeah, you can on the x squared piece and make it 2 log base 3 of x. And then there's nothing else to do to log base 3 of y. This would be the most simplified and expanded form of that. So I always kind of look for those things that can simplify. Doesn't come up a ton, but it does come up every now and then. You could simplify something. And that can definitely be helpful when you're solving an equation, because you can make we can turn that into a regular number. It's a lot easier to do than if it's a log, right? Log. Let's do log base 2 of x square root of x squared plus 1. X and then square root of x squared plus 1. So split it apart. And this is where some stuff from Algebra 2's got to come back here. The first one, obviously, there's nothing going to happen with that first part. But the second term, a square root is what exponent? 1/2. So this is a 1/2 power. So I can rewrite that as 1/2 log base 2 of x squared plus 1. And I won't split apart x squared plus 1 because it's addition. We don't have a property for splitting apart addition. We don't have a property for splitting apart multiplications and exponents and additions. Okay, so the square root becomes a 1/2. A cubed root would be 1/3, and we can work with it like that. So keep that in mind as you're going along. Let's get a little bit more stuff going on. Maybe log base 4 of x squared y over w. This one has a couple of different ones going on. Obviously, there's some division, so we know there's a subtraction problem going on. So if I just take it one step at a time, I could go log base 4 of x squared y minus log base 4 of w. And then log base 4 of w doesn't expand any further. It's done. But log base 4 of x squared y can split apart and be 2 log base 4 of x plus log base 4 of y minus log base 4. That 2 goes on the first one only because it's only on the x, and then it doesn't go on the y because the y didn't have an exponent there. So splitting that apart. If you want to do it in 2 steps, you can do it in 1 step. That's even better. Okay. So as you do more of these, you'll feel more comfortable with doing things in single steps. All right, so this has got a little bit more. So what's this one going to become? Close. So he said minus 2 log 2c. What about that d? This is the part that was, I say it's wrong. Where's the d? Down here in the denominator, right? So it's divided, so it should be subtracted as well. Anything that's in a denominator should be a subtraction problem, part of the problem. Log base a of the square root. Let's do cube root of xy. Well, what do we know about cube root? It's the 1/3 power, so it's xy to the 1/3. And then log rule says that 1/3 can do what? Go to the front. But then what can happen? Okay. So that would be log base a x, log base a y. But I had a 1/3 times all of that in the front, right? So I could put a 1/3 in parentheses like that. Or it could be written 1/3 log a x plus 1/3 log a y. Short answer, if it's a short answer question on the quiz, I'll take either of those. Most likely, if it's multiple choice, it's going to be the second version of that. But short answer wise, I'd take either way for that. But this is most likely the answer choice you're going. Well, if you're checking answers in the back, that's probably how they're going to write it. And again, depending on what we're doing as far as solving an equation later on, which one of those is the best for us? If we're condensing, we got to be able to recognize, hey, this could be rewritten as that up there. And that's what we're doing next is condensing. Condense or write as a single logarithm. Condensing, just trying to take an addition, subtraction problem. Maybe it's got some stuff multiplied or something on there. But we're trying to take something like this, log base 2 of 6 plus 3 log base 2 of x, and we want to condense that into a single logarithm. So we look at it and we say, okay, if it's addition, we know it's going to turn into multiplication. If there's a number in front of the log, we know that number should have been a what? Power. So this 3 is going to go up here, and we're going to end up with a log base 2 of 6x cubed, right? And then if we're, kind of the end goal here is eventually we're going to use this to solve equations. It's much easier to get rid of one logarithm than it is to get rid of two separately. Okay, so that's the idea here. We can condense that down to 1. Then it's only one move to get rid of it, as opposed to trying to get rid of two different ones. Let's do this 1/3 natural log of x minus natural log of x squared minus 1. You write that as a single log. What's it going to be? Yep. So cubed root coming from the 1/3 power. Just changing that back to a root. Technically not wrong if you wrote it x to the 1/3 power. It's still technically correct because those are equivalent things. So I would take either one on a short answer type situation. Let's do one that's seems a little long, but that's the whole idea here is we're taking something that's this long and trying to write it as 1. So let's take log base 5 of x plus log base 5 of 9 plus log base 5 of x squared plus 2 minus log base 5 of x minus 3 minus log base 5 of y. So pretty long one there to deal with. All right. So what operations do we have here?
Subtraction and addition and so multiplication.
Yeah. So subtraction and addition, and so that's going to turn into multiplication and division, right? So what all is going to be multiplied together?
Anything that's being added and anything that's being subtracted.
Okay. Anything that's all the things that are plus signs or positives are going to be multiplied together. And then separately, the ones that have minus signs are also going to be multiplied together. But what's the difference? Yeah, the minus signs are going to be in the denominator. The plus sign, things that are positive, are going to be in the numerator. So that makes this a little simpler if you think about it in that way. So the numerator of our fraction is going to be what? Yeah. And I wouldn't multiply that out. Period. Don't do that. And then on the bottom, we're going to have y times x minus 3. And I just write it that way just because it's the more acceptable. If you wrote x minus 3 times y, that's fine too. But that big long statement there or expression can be condensed down to that one. It's pretty easy, not too bad. Let's do one more. 3 log of x minus log x plus 2 log x plus 5 minus 3 log x minus 2. So this one's similar. Few extra things in there, and then a little shuffling happening there. What's the base on that log? 10. Not that that's important for this particular problem, but once we get to solving equations, it would be. So the log base 10. So this one's similar to the previous example, except for things are not grouped together as nicely. But as far as work goes, it's the same kind of problem. So We know it's going to be multiplication and division and some exponents. What's going to be our numerator? X to the third. So this piece, it's a positive piece, so we know it's going to go in the numerator. This piece has a plus sign in front of it. It's positive, so we know that's going to be numerator. And that means everything that has a minus sign in front of it's going to be denominator stuff. So I think it makes it so much easier to think about what to do if you think about it in that way. Okay, so x cubed, and then x plus 5 squared, right? And then in the denominator, we've got x, and then x minus 2 cubed. And that's rewritten as one single logarithm. Not, again, this is exactly the same thing you've done in Algebra 2. It's not any different. There's no extra things in this. Normally, if it's something we did in Algebra 2, we put something else with it. But this is exactly the same thing that you've done in Algebra 2. And so 456, 13 through 28, and then 37 through 77. I just do the odd ones on those, but use your discretion about that. But pretty straightforward as far as that goes. I mean, it's not crazy hard stuff.